Determine whether the integral from 0 to 2 of 1 over e minus e to the x is a proper or improper integral. Okay. So neither of the bounds are infinite. So it's not going to be one of those type 1 improper integrals. Remember, we've got two possibilities. Type 1, where some of the bounds are infinite, or type 2, where the function at some point, or maybe multiple points, in the interval, in this case 0 to 2, tends to an infinity. So clearly it's not type 1, but is it type 2? Well, we have to check, does this function here tend to infinity or negative infinity between 0 and 2? Does it have any sort of vertical asymptote? Now the 1 up here is nice and fixed. We can trust in it. So the only way we're going to get a vertical asymptote is if the denominator here starts getting very, very small. Because 1 divided by a very, very small number will be very, very big. So it'll tend off to infinity. So it's natural to ask about the behavior of this denominator, e minus e to the x. Does it get very small? Does it actually approach 0? Well, if we rearrange it, e to the x. Now you could introduce some logarithms here. You could say, well, e is e to the 1, and if you've got the same base, the only way for the numbers to be equal is if their exponents are equal. So we're going to have a vertical asymptote at x equals 1. Specifically, I think it will head to negative infinity on one side and positive infinity on the other side. We don't actually need to work that out. We just notice the denominator gets very small as x approaches 1, and 1 is in the interval we're working with. Okay? 1 is in between 0 and 2. So yeah, we've got a problem. It is a type 2 improper integral. So yes, it's improper. And I might even tell them it's type 2. And if somebody really asked for it, I would explain it. Okay, this function has a vertical asymptote at x equals 1. So we can't just trust fundamental theorem of calculus because this function isn't continuous. At least not from 0 to 2.